We have seen two sample t-test with unequal variances. Now we will see paired sample t-test. We have already discussed what is paired sample means. There is only one sample that has been tested twice, before treatment and after treatment. Like this, here we have one sample of size 4. Their math scores before completion of the mathematics course are test 1 results. These test 2 scores are after completion of the maths course. Here we have one sample, this one. Here test scores are taken twice, before the course completion and after the course completion. Second type of paired sample is there are two samples, these two samples, but researcher match them according to certain variables such as age or gender. This type of sample is called matched pair. We have 4 observations here. These two are matched as one pair based on age, and these two are matched as another pair with different age group. In these two cases, samples are dependent. For this kind of samples, paired sample t-test will be used. This test also sometimes referred as paired difference of means test. Some of the examples are sugar levels before and after treatment, heart rate before drinking cup of coffee and after drinking cup of coffee, alcohol consumption before and after marriage, math scores before completing the course and after completion of the course, test scores based on age groups. All these are types of paired samples. Test statistic T is calculated with this formula xt bar minus mu d by st by square root n. Statistic T follows T distribution with degrees of freedom n minus 1. Here xt bar is the mean difference between pairs. St is the standard deviation difference between pairs. Mu d is the hypothesized mean difference. Assume here xt bar follows normal distribution. Let us see one example problem. This test 1 scores are the math scores before completion of the course. Test 2 scores are the math scores which are taken after completion of the math course. Conduct appropriate hypothesis test to check whether the average math score is more after completion of the course. Means mu d greater than 0 at 95% confidence level. These are the values of mean and standard deviations for two samples. Sample mean difference between pairs xt bar is 9.25. Standard deviation difference st is 4.74. First, we need to formulate null hypothesis and alternate hypothesis. Here, our interest is to check is there any improvement in the math scores after completion of the course. Here, we are checking for the difference, so it is the alternate hypothesis H1. Null hypothesis assumes no difference between math scores before and after completion of the course. So, H0 mu d less than or equal to 0. Let us assume alpha 0.05 means 95% confidence level. Here we don't have the idea about the population standard deviation. Sample size is not large, means less than 30. So assume population difference xt bar follows normal distribution. So we can perform paired sample t-test. Then t statistic xt bar minus mu d by st by square root n. If we substitute the values, t statistic value will be 3.9. Since it is right tail test, rejection region will be on one tail. Here degrees of freedom is 3. T critical value for degrees of freedom 3. For one tail test at 95% confidence level, it will be 2.353. T statistic 3.9 falls within the rejection region. Here T critical value is 2.353. This T statistic greater than this T critical value, so result is significant. We can reject this null hypothesis at 95% confidence level. Means after completion of the course, average math scores is more.